this episode, the insiders debate whether AI is an application in its own right or simply a tool. Then, Arvind Rao, Global Director and Head of Product Management and Industry Solutions at Rockwell Automation, joins Brandon and Rich to discuss how the automation equipment supplier and its customers are faring with smart technology rollouts in the manufacturing sector. The three discuss the most successful starting points, potential roadblocks, and ways that internal and external Rockwell customers have successfully implemented industrial IoT technology in new and legacy installations. Later, Associate Editor Tiera Oliver asks a philosophical question: can an AI create? There is significant litigation around patents filed on behalf of an AI called DABUS, as technologists, researchers, and courts worldwide dispute whether patents should be awarded to entities other than natural persons. Tiera takes a deep dive into how this debate is unfolding in South Africa, where a legal team from the University of Surrey has brought the case in front of the Companies and Intellectual Property Commission.
Welcome to the Embedded Insiders. I'm Brandon Lewis, Editor-in-Chief of Embedded Computing Design. I'm here with Rich Nass, who's the EVP and Brand Director for Embedded Computing Design. How you doing, Rich?
I am doing great. Thank you very much. I'm actually just back from my first trip to Silicon Valley in about 2 years. Pretty crazy. I mean, obviously, everybody knows why nobody's traveling. I took a trip, as you know, a month or two before that, to our office in Scottsdale. This was the first time out to the Valley to see the people I used to see on a very regular basis. Man, it was really nice to get out there and to do meetings face to face that weren't over Zoom.
So that's why you have a tan line in the shape of a mask on your face.
Well, I live in Florida, so you know.
So how was it out there? Anything pique your interest?
Yes. Somebody said something to me, which I thought was really cool. I'll actually give the name. I was with Chooch, who, as you know, we've been working a fair amount with them lately, and they do a lot of AI stuff there on the software side. But I asked them a question about AI applications, and he looked at me kind of funny. He said, "What do you mean an AI application?" And I said, "Well, applications that use AI." He said, "Well, that's exactly right. AI on its own is not an application. AI is performed to do an application, not the other way around." And I sat back and I thought about it for a minute. And we've been talking about AI applications for a very long time here. And I think we might be looking at it from the wrong perspective. The application is whatever it is, in industrial automation or automotive or medical healthcare, and you use AI to perform that application. Does that make sense?
Yeah, it does. There are a couple of things. I do think there are AI applications depending on who you're talking to in the industry. You know, there are, depending on where you are in the value chain, there are people who are developing AI. So to them, the application is AI. But not
the OEM. You're just talking about the AI developer.
Correct. The AI is the application for them, or anybody, you know, who's developing TensorFlow and, you know, OpenVINO. You know, the AI is the application in those cases. But I think that's just sort of semantics. And yeah, I do totally agree that, yeah, we're talking about having AI being used in a specific application or in a use case. In most cases, except for the cases where the AI may end up building its own application or building its own AI, the AI is used in an application. But I think the reason that it's easy for us to fall into that verbiage that we use, AI applications, is that there are a lot of applications now that either wouldn't exist or wouldn't be able to function the way that they would without AI. I mean, you know, it's great that we have industrial IoT and smart manufacturing, but without some level of AI, it really doesn't work, right? I mean, there's no person or even relatively simple or average computer program is going to be able to crunch all that numbers. You need AI to do it.
A lot of these applications we've been talking about for a very long time, and I was actually just about to write about this. It's really nice to actually see some of this stuff in action, and I did see an AI application. I shouldn't say that. I just said that doesn't exist. But I was with Aver Media, and they are a Taiwanese-based server company who imports AI onto their boards. And they brought me over to a Walgreens. Oddly enough, I see the perplexed look on your face. And
Taiwanese Walgreens?
Excuse me?
Taiwanese Walgreens?
In Orlando, Florida, plain old Walgreens.
Okay.
And they said, walk up to the refrigerator section, where they keep drinks and stuff. Okay. So I walk up, and as I got near the refrigerator door, the door recognized a person coming up and flashed up what was inside the refrigerator. So it wasn't a transparent piece of glass, obviously. It was a giant display that was looking just like a piece of glass. And you have to look hard to know that it's not a piece of glass, that it's actually a display. And they hadn't enabled it yet, but they do have the technology that's ready to go. I actually think there's legal things that they got to work out. They can tell whether you're happy or sad or tired. For example, if you're tired, it'll pop up the Gatorade for you. And based on different things, it'll show you, what's on sale and what it thinks you should be buying, or if you're in the frozen pizza section or the milk section. And it was really nice to see some of these things we've been talking about for a real long time actually in action. I was really impressed with what they were able to do.
Don't sign up for the Walgreens rewards program, because they're going to have all of this information on your mood.
Well, my mood doesn't change, that.
Right. Yeah, that for sure. That's like we were saying, that's an AI application, in that without AI, it doesn't exist, right?
No, it doesn't work. It definitely doesn't work.
And you bring up an interesting point. Earlier, you were talking about different, other types of AI beyond, computer vision and facial recognition. An interesting question is, what technically is AI? Because now there's a whole bunch of stuff that's grouped into AI that I don't think that we would have called AI 10 years ago. Decision trees and support vector machines and, all those things have existed, and they're actually being used in a lot of applications and have been being used. What's a threshold value? Make a decision based off of, this threshold being breached. If this threshold is breached, then turn this motor on. And if that motor is running at the same time, then do something else. That's a decision tree. But it's also, AI now, right? Is that AI?
At the end of the day, they're all just ones and zeros.
Exactly. So actually everything's an AI application.
Well, backing up a little bit, what we talk about, and we don't use the term, but it's really machine learning, what we're doing. AI is a lot broader, and it's things like when you're on the telephone with somebody and they can understand your voice and figure out what you're trying to say. Those are things that we generally don't get involved with, but it's the machine learning, having the machine do different things based on what it's learned by past experience and conditions and sensors. That's really what our folks are working on.
Correct.
And AI is just this catch-all phrase that we get sucked into using.
Right. And I think that that's a really important distinction. And maybe this is how we start talking about AI and ML applications moving forward. It's not necessarily the fact that the machine...
No. There are not AI and ML applications. We established that already.
There are some. If you couldn't do it without AI or ML, it's an AI or ML application. But
yeah, it's still a security application. It's still a facial recognition application. It's still a predictive maintenance application, but you use ML to drive that end application. I'm a converted now.
Is it tomatoes or tomatoes?
From New Jersey, it's a tomato.
Next, Arvind Rao, Global Director and Head of Product Management and Industry Solutions at Rockwell Automation, explains how today's industrial organizations can capitalize on data models and frameworks to turn old factories into smart factories.
Rockwell's in a pretty interesting position in that you can be both a producer and a consumer of industrial IoT technology. So that gives you insight into, I don't know if you guys are using some of the lessons learned in your own operations and feeding that back into the products that you create and how you're using that to serve your customers, and just where you sit in the landscape? And I guess that's the first question.
Yeah, no, it's a great question. Like you said, we are a manufacturer. We are a global manufacturer with plants all over the world. We make a lot of hardware products. And so, we face the same challenges as most of the customers we serve. And so Rockwell's been on a sort of digital transformation journey way back, even early 2000s, when we started looking at how we want to deploy ERP systems across our network, our supply chain network, to manage the supply chain better. So we have a pretty large SAP implementation, but that's where we started. So we've been on a long-term journey. And so we went through SAP implementation. We actually implemented our MES, FactoryTalk Production Center, our entire MES portfolio in our plants. So we went through that journey, and as part of that journey, we measure every year what quantified value are we getting from the investment, because it does a really nice job quantifying inventory turns, productivity, labor utilization, asset utilization, all the quantified metrics, because we baseline we're financially well managed, is what I would say. So we've done that, and so we went through SAP, we went through MES, and then as we've gone through IoT implementation, so we're leveraging some of the technologies that we sell as well through that as part of FactoryTalk Innovation Suite. And now what we're actually doing is we're implementing augmented reality. When we looked at what happened with COVID and the need to retrain a new labor force, bring in new people into our plants, remotely supervise production management, things like that, we've seen some huge benefits in implementing augmented reality in our plant. So I would say the simple answer to your question is yes. The longer answer is that we've been on this journey since, like I said, early 2000s, and we've gone through a nice phased approach. Every year we stop and check in to make sure that our investments are meeting the ROIs that our executive management require, and we have easily met those financial metrics. So there's real value for digital transformation. Our supply chain measures itself on on-time delivery. So for example, we've improved on-time delivery from, let's say, the low 80s to the low 90s. So big step up in on-time delivery. That's a big metric that we look at. So when we send you the case study, you'll see the improvements there. We measure back to sort of our P&L in terms of just how much inventory we're carrying. So we've reduced our inventory turnover days. We've dramatically reduced that. I don't remember the number at the top of my head, but it's in our case study that we can send you. So that's a big metric for us in terms of ROI. We also look at asset utilization to make sure that our lines are running with like the highest OEE possible. We are not a large scale, like mass volume manufacturer. We do have, various, we have many SKUs. And so we have a sort of a mass, more of a customization flexibility need. But we do make sure that we run OEE, and that's a key metric for us. And then, just overall efficiency in terms of productivity and productivity gain. So we have a 4 to 5% productivity gains metric that we have to hit in our supply chain every year, right? And so that's another measure for us. So, what I was talking about, the journey we're on, or we've been on, is the internal Rockwell plants. But when we go to customers, we have a very similar approach. We have a very strong consulting value-based methodology that we walk customers through to understand, hey, where are you in your digital maturity? Are you more advanced? Are you just starting? And depending on where you are, we have the right technology and services capabilities to get you going on to accelerate your journey. So we take the very similar approach with external customers to go through that journey of where are you? What do you have? Let's do an assessment. Okay, step 1 should look like this. Step 2 is like this. Step 3, and then as we go take you on your journey, we quantify value along with you so that we're making sure that you're getting value from investment. So we take a very similar approach externally as well.
Do you use internal customers as beta testers, or are they a finished product just like an external customer?
It's a mix of both. Many times we will use our internal plants for beta and for use cases to make sure that we are using our manufacturing facilities to it's a good way to improve them as well, but it's also a good beta test for some of the technologies we bring out. So in my business, we do that quite frequently in deploying some of our technologies on our own plants first before we take it to customers.
There are obviously some low-hanging fruit there with specifically predictive maintenance and then asset monitoring. Would you agree that those are the obvious, first places to start when you're implementing industrial IoT? That's what we hear a lot about.
Yeah, I would not say predictive maintenance is a good place to start.
Okay.
To be honest, a lot of where customers get started is just basic visibility, right? I just want to be able to connect my machines, connect my production lines, and I want to see how I'm doing. So asset health, is my machine running? If it's supposed to run 20 hours a day, why does it only run 16 hours? Like, why do we stop? Like, what are the reasons for stoppage? Because that affects things like OE and metrics that you normally hear from manufacturing, right? So a really good place to simply start is if I'm writing a lot of things on whiteboards, if I'm using a lot of paper, and then I've got like a weekly report. Most customers are still looking at history. It's not about, yes, something bad happened last week, but that event's happened and gone. Like, there's nothing I can do about it. The question is, what can I do about what's happening right now? So you need real-time visibility. It's kind of the point. So a really good place to start is that if you're using whiteboard to write down, last hour I made 80 parts. Like, I'm like, what are you gonna do with that? Right? And so the question simply becomes, a good place to start is just gaining real-time visibility into what's happening in your manufacturing facility, in your operations, and aggregate some of that information, say across lines, across plants, and simply to be able to say, hey, plant A makes the same product that plant B does. Why does plant A run more efficiently than plant B? Or why does on third shift plant A use more energy than on first shift? It's running the same product. Like, just to make basic benchmarks and comparisons is a great place to start. If you're doing nothing. Predictive maintenance is a buzzword. Like, there are multiple steps you would take. So predictive maintenance means that you need to have a machine learning model that's predicting something. Every machine learning model, I don't care what the marketing hype around it is, needs data to build the model. So if you're not even collecting any real-time data and you're not assigning when this failure happened, this was the reason, like this was the sort of conditions of operation, then the machine learning model cannot connect any dots. So machine learning is no magic, right? It's a database science. So saying I'm going to start with predictive maintenance when I'm writing everything on whiteboards means like you're not going to get there, right? So you have to start collecting and looking at real-time visibility before you can get to predictive maintenance. One of the things that we advise a lot of our customers is predictive maintenance is great, but your real value is optimizing your running process. Because predictive maintenance generally generally a lot of stuff doesn't fail, to be honest, right? In the industrial world, it's not like catastrophic failures are happening every 5 seconds, right? Generally, machines don't fail all the time, right? Otherwise, we'd have bigger problems. Like, it's your car. Your car doesn't break down every time you turn, you press the brake, right? So it'll break down. Well, depends on what car you drive, but generally, cars don't fail all the time. So machines are the same way. They don't just like fail. So you might find that one event like that might happen. But if you get a 1% improvement in your process that you're running on like 1% yield or what, that dollar savings is way bigger than any predictive maintenance. That's kind of like we make sure that our customers understand that part of like trying to find that one catastrophic failure that might happen once every 3 years. It's still better to save 1% in your running process, right? As opposed to like going for the moonshot kind of thing, right? So
you're really just talking about for asset monitoring, pulling data off the system. There have been versions of industrial Ethernet that have existed for a long time that you could, just drop an Ethernet file system on top or an Ethernet stack on top of whatever your controller is, and then just start pulling data into an ERP and monitoring it that way. But it seems like there has been a lot of resistance to that. And I'm not sure if that's just a function of tradition or if there are concerns that are legitimate, because if you start talking about, oh, there's cyber threats and whatever, well, yeah, I mean, you can just keep this on an internal network. This doesn't have to connect to the internet. So what are some of the big roadblocks that you're seeing that are preventing people from doing this?
So there's a lot in your question. You are correct. There have been multiple ways to connect assets to any sort of database system and do what we just talked about. So there's a couple of things. A is that there are so many different protocols in any manufacturing environment. Ethernet, Profibus, Modbus, I mean, you name it, everybody's got a protocol. So there's always been a challenge of bringing all those systems and protocols together. And the reason I say systems is because just looking at any one thing in isolation doesn't give you value. So you hear a lot about, I can connect my sensor to the cloud. And my question always is, what are you going to do with it? Right? So the sensor is always just giving you one reading. So it might say the temperature outside is, 40 degrees. I'm in Milwaukee, so it's about 40 degrees. But I'm like, what are you going to do with it? Like, okay, that's good. But the question simply becomes, so for a manufacturer, there's multiple systems. So you need data in context. Then there's value. So for example, what you need to be able to say is, if my oven temperature is supposed to be running at 150 degrees because I'm making chocolate chip cookies, and chocolate chip cookies need to go through the oven, there's a 3-minute bake time at 150, right? And so just telling me that the temperature is now 160 doesn't help me. So you got to say, I'm making chocolate chip cookies. My conveyor is running at a certain speed because there is how long the cookie dough stays in the conveyor is also a function of what the temperature needs to be. So you could get away with 140, maybe if your conveyor is running slower, right? You get the point, right? Then there's also like, what's the humidity in the oven? Who's the operator running it? Like, there's so many parameters that in context now tell you something. So just customers have for years just pushed data to something and say, well, I don't know what I'm getting with it. Without data in context. So you might go from chocolate chips to oatmeal raisin. Now that you might need to run it at 180 degrees. I don't know, I'm just making stuff and I'm getting hungry as I'm giving these examples. But like, my point simply is that, so now just saying I went from 160 to 180 doesn't mean anything. Maybe 180 is good because you're making a completely different recipe, right? And you're running a different oven. You might be running in Arizona versus in Milwaukee. And it's just that the humidity and the plant environmental conditions are completely different. You have very dry air versus very maybe moist air, right? So humidity plays a big part in a baking operation. So when you start connecting, Rockwell's philosophy always has just sending sensor data to the cloud or sending sensor data to ERP doesn't mean anything. So customers are still struggling with this. We believe in providing data and context. So if I give you a structure for your data, it's the oven temp, it's the cookie recipe, it's this batch, it's this manufacturer oven, you're in Milwaukee. Like, if I give you all that package, now you can tell me whether 150 is a good temperature or not, right? And then there's value. Just saying 150 and sending it to an ERP, it doesn't mean anything.
So how is Rockwell helping its customers moving from being, just providing a box or a system to some of that data modeling and the structure and the framework around putting the context on that data that's being captured?
Yeah, great question. Very near and dear to my heart because that's core to the business that I run at Rockwell, right? And so we believe in this sort of the edge. We'll just call it edge. It can be a controller. It can be an industrial PC. It can be a data center. Like, the last point before anything goes to the cloud or goes outside the plant. Let's just define it that way, right? So we are providing this kind of data modeling and context right at the edge. So our differentiation always has been is that most of this kind of information comes through the controller, and Rockwell has a dominant share in the controller space, right? So that's where we got started. A lot of this information sits in the controller. So that data model that I described of like that data, that context is actually in the controller. Most people don't realize that, but it's in the controller. So our approach always has been is like, how can I leverage that data model that already exists where a customer has invested millions of dollars in implementing that platform? And now I'm not asking them to redo something. I'm not asking them I'm taking that data model out of the controller And at the edge, I am now surfacing that data model and making it available to higher level applications. So we're giving customers the ability to say, hey, look, if you've got this in your controller and you've got a Rockwell controller and you buy the edge solution from Rockwell, I can automatically, without the customer having to do anything, take that data model and context out. And then I can move it to wherever you want it, right? I can move it to Azure Cloud. I can move it to ThingWorks. I can move it to my MES. I can move it to a supply chain system. Doesn't matter where, right? We can get that data model in context. Now, if you're not a Rockwell Controls customer, you can still leverage our technology and you can build that data model in context at the edge, which is closest to the source of data. Don't try to do that in the cloud or somewhere because it becomes very complex and expensive. Do that right at the source of data. That is kind of our pitch, because we hear a lot of startups with like, I can connect your sensor to the cloud. And I'm like, we can do that too, but like, I don't think there's any value there, right? Because it's one data point and it's not going to do anything for you. And to recreate that data model and context in cloud is very expensive, right? So we help customers do that right at the edge. And then we, have a very strong partnership with Microsoft, and we provide value in cloud. So a Rockwell Managed Cloud Service built on Azure, we're able to provide context, data, warnings, work order. We just acquired a company called Fix in maintenance management. So we can automatically trigger, hey, I just saw something at the edge. And if you're using Rockwell's maintenance management system with Fix, you can trigger a workflow automatically and say, hey, something's wrong with that process. Something's wrong with that asset. Go fix it, right? A signal goes to a maintenance manager on an iPad or a phone and go do something. So that is kind of how we approach the problem.
What percentage of your customers, I guess, are on the road to doing some of this industrial IoT stuff versus still, I guess now we'll call it the dark ages, still not connected, still have all these systems operating in isolation and not pulling value out of the data?
Yeah. So I would almost say like close to 100% of our customers are either talking about it, doing it, have a plan, have run a proof of concept. So almost like everybody, I was just at Automation Fair last week, our biggest customer show, and like I couldn't find a person that was like, oh, we have no plans, right? Or we're not even thinking about it. Like there's not a single person that I spoke to. So which has changed quite dramatically, right? 4 or 5 years ago, oh, that sounds cool, but we don't have a plan, right? So everybody's got something going. They're running a proof of concept. They're doing something about it. So that's point number one. I think there's still, now, from a mass adoption perspective, I might give it more of a, a lot of customers have proof of concepts and pilots, but people that have like just adopted it, say we did it in one plant and now we're scaling it at 40 plants, right? That's maybe more of a 50% number, 50 to 60%. Like 3-4 years ago, that was probably like 15 to 20%. Now it's more like 50 to about 50% saying, yep, we did it, we got it, we know where we're going, and we're going to go scale, at multiple plants, like multiple being more than just one, right? And there's a handful of like, I would say 10 to 20% that go, yep, we've done it now at 5, 6, 10 plants. We're going to take it across our entire network because I have 100 plants, and this is the ROI meets our needs, and there's definite value. And so I think customers are moving. The movement has accelerated. COVID has actually, interestingly enough, accelerated a lot of activity in digital, remote connectivity, remote management, moving to cloud. You see a lot more customers moving core applications to cloud. And even the security conversations are changing, right? So a lot of IT, OT, the IT folks are getting involved. And actually what they're finding is that this whole thing like, oh, I don't want to connect anything to the cloud because it's like, I'm scared of security. And what we find, and this is true, is that cloud security is way better than any security that somebody can implement in a plant environment. And, there are plants running like things that haven't been patched in like 20 years, right? That are so open and vulnerable. All you need is somebody to stick a USB drive and you can bring the whole plant down, right? And so the whole this misnomer of like, if I'm not connected, I'm secure. That has just, we've shown now, and you've seen all the news, that is just the cloud is way more secure than any security that somebody thinks they can implement in the plant by themselves, because they're just scared. A, they're scarce on IT resources. They just don't have enough people. B, they don't have the competency, right? How many plants are running around with like top-notch security personnel in the plant? You can barely find one IT, person sometimes in a plant anymore, because they do manufacturing really well. They're not cybersecurity experts, right? So I think we're starting to see that shift of IT saying, you know what, the cloud's actually pretty secure, right? I do my banking in the cloud, all my email, Microsoft 365, everything is in the cloud, right? All my 401k, like everything is in the cloud. My stock like all my financials are in the cloud. My banking's in the cloud. My health and patient data is in the cloud, right? And so I think we're starting to see more cloud movement in IT.
For more information on advancing the industrial IoT, check out the Capabilities tab on rockwellautomation.com. Next, Associate Editor Tiera Oliver questions whether AI systems should be afforded inventor rights following a landmark decision in South Africa to grant multiple patents to the AI system known as DABUS.
It's official. Whether or not AI has rights is no longer just in the realm of science fiction. The University of Surrey recently filed an application with the European Patent Register on behalf of DABUS, or Device for the Autonomous Bootstrapping of Unified Sentience. And for the first time, a patent was awarded to a non-human entity, well, at least temporarily. Not only was this the first time an AI was awarded a patent, but a university press release says that this was also the first time an AI was named as an inventor in a patent application, and the first time an AI was named in a patent application, period. According to the Artificial Inventor Project, which seeks inventorship status for artificial intelligence systems, DABUS is a creativity engine wherein controlled chaos combines whole neural nets, each containing simple notions, into complex notions, for example, inventions. The representation of ideas takes the form of snake-like chains of nets, often involving millions to trillions of artificial neurons. In short, DABUS arranges a network of neural networks that imitates a human brain alongside blockchain-like concepts of distributed documentation, understanding, and approval. This combination allows the system to comb through bits of data to forge new connections and generate its own ideas. So far, DABUS has two inventions: a container based on fractal geometry and a neural flame. According to Raconteur, the container can be likened to a cup that uses a series of bumps and bulges connected by fractal patterns like those found on a snail's shell. The neural flame is a light source based on a blinking frequency that is difficult for human eyes to avoid, making it potentially useful in search and rescue missions. The patent applications were filed by an international team of lawyers and researchers led by the University of Surrey professor of law and health and author of The Reasonable Robot, Artificial Intelligence and the Law, Ryan Abbott. Abbott filed the patents on behalf of Dr. Stephen A. Thaler, President and CEO of Imagination Engines in St. Charles, Missouri, and the designer of DABUS. At the end of July 2021, South Africa's Companies and Intellectual Property Commission, which works cooperatively with the European Patent Office, approved the beverage container patent application that classified DABUS as the inventor. However, Thaler's name remains on the application as both applicant and grantee. Although AI is still in its early days, it's somewhat surprising that this marks the first time an AI has been awarded or even been considered for a patent. But it turns out that traditional patent and IP laws state that only a natural person can be labeled as an inventor or granted a patent, limiting patent rights to humans or their employers.
Historically, an inventor of a patent has always been a human being, although ownership of that patent is usually given to a company that employs a human inventor. While patent law in different jurisdictions varies with respect to how inventorship is defined, the DABUS team is arguing that when an AI has functionally invented something without a traditional human inventor, it is not appropriate to list a person as an inventor for that patent.
Says Abbott. Yet, South Africa's patent law does not explicitly state the requirement of an inventor being a natural person. And because it does not, it has become the site of what Professor Adrian Hilton, director of the Institute for People-Centered AI at the University of Surrey, believes is a landmark that recognizes the need to change how we attribute invention. According to Hilton, we are moving from an age in which invention was the preserve of people to an era where machines are capable of realizing the inventive step, unleashing the potential of AI-generated inventions for the benefit of society. According to Abbott,
the School of Law at the University of Surrey has taken a leading role in asking important philosophical and practical questions, such as whether innovation can only be a human phenomenon and what happens legally when AI behaves like a person.
Of course, not everyone sees it that way. Following South Africa's decision to grant the patent naming DABUS as the inventor of the Fractal container, the worlds of AI and patent law have clashed considerably. Some believe that granting patents to AIs will make it harder for human inventors to secure patent rights. Others think it will result in IP law chaos in the form of patent trolling or constant paralyzing IP infringement litigation. Others still say this paves the way for AIs to hold and exercise additional rights. Outside of South Africa, DABUS patent applications are currently pending in Canada, India, the Republic of Korea, China, Taiwan, New Zealand, Israel, Brazil, Switzerland, and Saudi Arabia. The applications are in the appeals process in the US, UK, Germany, Australia, and the European Patent Office. As for the US, a report published in October 2020 from the United States Patent and Trademark Office revealed that the vast majority of respondents to a request for comment believe that ownership of a patent or invention should remain exclusive to natural persons or companies via assignment. However, there is some consideration of expanding ownership to a natural person who trains an AI process or who owns or controls an AI system. As for the team that has filed DABUS patents worldwide, they plan to continue arguing that, while patent law in many jurisdictions is very specific in how it defines an inventor, the status quo is not fit for purpose in the Fourth Industrial Revolution.
To learn more about DABUS and AI patent rights, visit https://artificialinventor.com/DABUS/.
Thanks for listening to this edition of Embedded Insiders. For daily news, videos, and podcasts, visit our website, embeddedcomputing.com.